Hello everyone, welcome to the chemistry class. So for today we are going to take a look into the different reactivities of alkene with sulfuric acid, with water. How does this particular alkene react with water under the presence of mercury acetate, sodium hydroxide, sodium borohydrate, this particular reaction name, and of course we are going to take a look as how these alkenes are going to react with the oxidizing agent under acidic conditions, under basic conditions, and finally we are going to take a look into how it reacts with ozone and what is the polymerization techniques. Alright, so for now let's start our entire class with respect to the reactions. The reactions with sulfuric acid. Alright. So when we observe the reactions with sulfuric acids, okay, so you need to understand that whether we take an unsymmetrical alkene or whether we go with respect to asymmetrical alkene is concerned. Okay, if it is an unsymmetrical alkene, it goes with respect to the Markovnikov's rule of addition. So now here, if I'm going to take into consideration of simple one, that is going to be the ethene. Alright, so we have ethene over here. And let's say this particular ethene is going to react with the sulfuric acid. In order to understand this particular reaction, let me open up the sulfuric acid formula. So, this is the sulfuric acid, right? So now, again, remember, here, this particular bond is going to be cleaved. It is going to be broken in such a way that hydrogen becomes positive, oxygen becomes negatively charged. Okay, so therefore, now, wherever you want, you can attach this hydrogen because the thing is, the alkenes are symmetrical in this case. Okay, so let's attach the hydrogen to the first carbon atom. So therefore, I'm going to get over here CH3. Alright, so here I have CH2. Okay, so now CH2 gets connected to this oxygen. Right? So when the CH2 gets connected to the oxygen, we are going to have here oxygen, sulfur, double bond O here, OH. Okay, you can represent either like this for your understanding, or we can also write it down as CH3, CH2, O, SO3H. Alright, so we can also go with like this, no issues at all. Okay, so whatever it is, the name becomes as the ethyl hydrogen sulfate. Okay, so remember the addition occurs if it is an unsymmetrical. If it is an unsymmetrical, the addition occurs in accordance with the Markovnikov's rule. Right? So this is the first thing that we need to know. Now, let's go one step ahead. And that is, if I'm going to take over here an alkene, how does it react with water? Okay, so let's take over here an reactivity with water. Okay, so in the reactivity with water, the first thing that we will take here into consideration is that we'll take an unsymmetrical alkene this time. So it is like CH3, let's take over here, CH3, let us have here double bond, CH2. Alright, now try to understand that water reacts with alkene only under the presence of certain drops of sulfuric acid. That means this particular reaction requires the acidic conditions. Okay, so when you have an acidic conditions, only that time this water breaks as H plus and OH minus. Okay, so as we have H2O, okay, this particular thing breaks down as H plus plus OH minus. Right? So now it is, can I write it down over here, H plus OH minus. Now it should follow the Markovnikov's rule. So in the Markovnikov's rule, how it is going to be? negative part of addendum attaches to that particular carbon atom of a carbon-carbon double bond which has a lesser number of hydrogens. So, carbon-carbon double bond, right? Lesser number of hydrogen, this fellow has no hydrogens at all, right? So, therefore, this is a position where your OH minus will attack. Okay, so when it happens, you are going to end up getting over here CH3C. This particular carbon attaches to oxygen of your hydroxy group. So now, what remains is CH3 down. So let's take over here CH3 down over here. So CH2, this hydrogen attaches over here. So now, this becomes as CH3. So this is how it goes in accordance with the Markovnikov group, right? So the name of this, if you see, the longest possible carbon chain is in a straight way. So 2 position and position number 2 is a methyl group. So I'll write it down as a 2-methyl. Okay, because 1, 2, 3. At position number 2, it's the methyl group. So 2-methyl, 1, 2, 3 means propane series. So propane. Alright. So propane 2-ol. Okay, so this is how the reactivity with water is concerned. Okay, now let me take one more example. So here, let us take into consideration of CH3 3 times C. Okay, CH double bond CH2. Okay. Okay, so now, if you take this particular thing into consideration, if this particular reaction occurs under the presence of mercury acetate, okay, and the solvent that they use is THF, tetrahydrofuran, okay. Now, if this particular thing is in continuation of the presence of sodium hydroxide and sodium boron. Okay, so now if this entire thing taken into consideration, and that time if this thing is reacting with water. Okay, so here this entire process, as what you see, is called as, this particular process is called as oxymercuration, demercuration process. So please remember the name, it is oxymercuration, demercuration. So here again the addition of water takes place in accordance with Markovnikov's rule. That means here again, whatever OH minus, negative part of the addendum, is going to attach to that particular carbon which has a lesser number of hydrogens. So we will get over here CH3 3 times C, CH, here is where the OH group attaches. Okay, so now here is CH2, from the water we have 1 hydrogen, that hydrogen will be inserted over here, so therefore we have the final product, and that is this one, right? So now we have one more method which we will discuss soon, wherein we are going to take into consideration of the diborons. Okay, so let's see that. On the other hand, if the unsymmetrical alkene, okay, and if this unsymmetrical alkene is treated with diborane under the presence of peroxide and in the basic conditions. So under such conditions, the addition of water takes place in accordance with the Crash effect. Okay, let's try to understand that. So here, if I am going to take into consideration of an unsymmetrical alkene, so like CH3, CH double bond CH2. Okay, so this is our propene, right? So if we take propene and if this addition is with the water molecule but under the presence of, what are the things that we have decided before? Under the presence of diborane, that is B2H6. Okay, under the presence of oxidizing agent, let's take oxidizing agent like a peroxide, and this entire thing is taking place in a basic medium, so therefore OH minus. So now the addition of water takes place in accordance with the Karash effect. Karash effect, in a sense, the OH minus that has been generated from this water molecule, right? It splits up into as H plus and OH minus, right? So now OH minus, what we have, that will be attacking in accordance with the Karash effect. That means it is going to attack to that particular carbon atom which is going to have more number of hydrogens. This is how it becomes. Now, this hydrogen attacks to the central carbon, so therefore it will be as CH2. So this is the 1-propanol. Right? So this is how the addition of water molecule has occurred under the presence of diborane, oxidizing agent, and in the basic conditions. Now, let's go one step further. Now here, we need to see the reactivity with oxidizing agents. Okay. So here, it all depends upon whether the oxidizing agent that we are taking is in a basic condition or is it in the acidic conditions. Okay, now let's take one simple consideration, one simple example as a symmetrical alkene reacting with oxidizing agent. Okay, so CH2 double bond CH3. Now it is going to react with oxidizing agent. Now when it reacts with solution of oxidizing agent such as KMnO4, now observe the condition. This particular thing should be in basic condition. Alright. Secondly, it should be a cold solution. Now, when we say cold solution, this thing refers to this cold solution of KMnO4 is called as, please note it down, it is called as the Bayer's reagent. Okay, it is called as the Bayer's reagent. So now, when this reaction occurs, what is going to happen? This thing gets oxidized. When it gets oxidized, it will give rise to vicinal glycols. Okay, so vicinal glycols means these are the particular products wherein we have 2 OH on the either side or on the adjacent sides of carbon. Okay, so therefore you are going to see here CH2. Okay, so now here what is that going to happen? This thing is going to oxidize. Okay, so this entire thing is occurring under the presence of solution, right? That means there should be water, there will be oxygen. So therefore, this oxygen will help us to oxidize it in this particular manner. Okay. So therefore, what it is giving us is ethane 1, 2. Why it is ethane 1, 2? Because 2 carbons. So ethane 1, 2. That means at the position 1 and the position 2. Okay, what do I have? I have OH. So di means 2. 2 all. So the product name becomes as ethane 1, 2 diol, and this is nothing more than under the class of vicinal glycols. Okay, so this is how it occurs. Now, in case if I have a symmetrical alkene itself, let's take symmetrical alkene, but this time I will take a little bit bigger one so that we can explain it in a better manner. Okay, so if this particular thing is oxidized, okay, but under the KMnO4, or you can also take it as K2Cr2O7, but it is an acidic condition. So when it is an acidic condition, it will give rise to either ketones or it will either give rise to acids. Okay, so here this symmetrical one gets oxidized to, please observe carefully, 2 moles. It will get oxidized at this particular point. Okay, so now it will give rise to CH3COOH. So it gives rise to acids. So here it is an ethanoic acid. Correct. So this is how the reaction happens. Okay, so let's observe how it reacts with ozone and how it gets polymerized. These are the two reactions which are given. The next set of reaction that we need to observe is called as ozonolysis. Okay, so basically it is like you're going to take a simple, let's say an unsymmetrical alkene. So let's take this alkene over here into consideration. So whenever an alkene reacts with ozone, that is O3, it will give rise to an intermediate compound. Observe the nature of intermediate compound, how it is. CH3, CH. Okay. Now this particular double bond is detached. Okay. Now we have an ozone, right? So this ozone is going to connect as these. And these set of compounds, we call it as ozonides. To be specific, for this particular reaction, it is going to be propene ozonide. Okay, so propene ozonide. So when this particular propene ozonide occurs, okay, and if we take this particular intermediate and then if we react this one with zinc and water mixture, it reduces. Okay, it reduces this, it breaks this thing down in such a way that the first one over here, that is CH3CH over here, what you have, this gets connected to one oxygen. So when it gets connected, it is nothing more like CH3CHO. Okay, it is giving rise to ethanol. Okay, so it is an ethanol. While the second set, that is this, it gets reduced and this particular bond gets cleaved, and we are going to receive CHHO. Okay, so it gives rise to a methanol. Okay, please observe Al, aldehydes. It is giving rise to a mixture of aldehydes. So this is the particular process of ozonolysis. Well, if you see the last case, and the last case is the polymerization. So in the particular process of polymerization, what do we have here? Here, when we take a thing into consideration like a simple monomers, a large number of monomers, they come together, they react together in order to form the molecules having a large molecular mass. Okay, such kind of substances we call them as a polymers. So therefore, if we take into consideration of ethene, okay, n number of moles of ethene, when they start reacting under the higher temperatures, what is the condition over here? We have the higher temperatures. Okay, under the higher temperature and pressure. Okay, and the next important thing is under the presence of a catalyst. Okay, so under the presence of a catalyst, what is going to happen is n number of these particular monomers are going to get connected to each other, something like this, in order to give, of course it is an ethene, but there are n number of molecules, so it will be called as polyethylene, right? So now, if I take into consideration of CH3, CH, double bond, CH2, okay, so same way, what we are going to do here, we are going to maintain a very high temperature, right, and a very high pressure, okay, under the presence of a catalyst. So when we have all these particular conditions, what is going to happen now? Again, this thing is going to get polymerized. Okay, so now please observe carefully. These are the things which are going to continue the chain. Okay, it's something like this. This one I'll represent over here. CH2, right? This is getting connected to the CH. So, this is getting connected to this CH. This CH is connected to CH3. Please observe the double bond. I did not represent the double bond there because it is getting polymerized. Okay, you will see where that particular bond is going to be used. So, this CH is going to connect to this CH3. So, here is my CH3. So, this thing continues n times. Okay, I hope you can name this and this. That is, I hope you people can name the reactant, and of course, you need to represent the name of the product. Where again? In the comments below. Okay, so when you take n number of moles of the reactant under the conditions of a higher temperature, higher pressure and the catalyst, it undergoes the process of polymerizations. Right? So these are the two examples for polymerization. In the second year, that is in the second year POC, you have an entire chapter based on polymerizations wherein we will be observing those reactions. Do take care. Thank you for watching. Bye.